So using binomial theorem, we need to expand the following statement. Before we do that, let's show a more intuitive way of it. Let's say you have three, each containing either a smiley face, a sad face, or let's say each of these boxes an infinite amount of these. Now let's say you want to choose at random one of these or three items from any of these three boxes. You know how to do that. You have three options and you're allowed repeat, right? Which means you can choose from the same box 3 times. So what does that mean for us? Okay, let's take a few examples. Let's say we had chosen, and this applies for all three boxes. If you had chosen from the same box 3 times, we would have 3 of the same item. Same situation, but instead of choosing the same one, we choose the same one except the last one. So these 3 choices and these 3 choices are all possible. And you can continue doing this for all choices. Basically, what I'm getting at here is that you can sort of replace these symbols. What we have here in a sort of visual way of understanding the binomial. I actually overcounted, right, because we have no z, which means we have sort of any sort of combination of this. And these 3 slots have the ability to be one of 2 options. It can be either an x or y, x or y, x or y. And this is sort of a few examples of the choices we could have made. So that's sort of a way to understand how these polynomials expand out. So each of these 3 choices we could have made, and it's 3 because we have either an x or y to choose. And in the case of this here, this is the same as x cubed, right? What is y cubed? What is x squared? Y x. Now that we have a conceptual understanding, let's actually get to how we calculate it. We know that the general formula is you have 2 factors in b to the power of n. You can expand this as the sum, where k starts at 0, times a of n minus k times b of k. Okay, so that's a formal way of doing it. And if you want to expand this a bit more, it's actually n factorial over k factorial times n minus k factorial. Okay, now that we have this general formula, let's expand it out. It's only 3 terms, so it won't be too difficult. So let's get 3 of these. When k starts at 0, so we'll do blue for k equals 0. When k equals 0, b to the 0 is 1, and n minus k is a to the 3. Okay, so this is the situation where we had a times a times a. Right? For my choices, which means we chose from the same bin 3 times. a times 3. Our k is 0. 0 factorial is 1. We have 3 factorial over, and this is 0 factorial times 3 minus 0 factorial. It's still 0 factorial. Now, what we have here is k is equal to 1 factorial. It's still 1. This time we still have b. 3 factorial over 2 factorial is the same as just. So here we have 3a squared. Now here, 3 here. K is now 2. 2 factorial. 2 factorial is still 3 minus 1 factorial is just 1. 3 factorial over 2 factorial. 3 factorial over 2 is equal to 3 times 2 times 1 over 2. These 2's cancel out. We just have 3. Here, this is 2. This is 2. 3 minus 2 is 1. So we have a to the power of 1. And then we have b squared. Here we have, of course, we have 3 here, 3 here. But our k value is now 3, and so is this. So is this 3 minus 3 is 0. A to the 0 is just b to the 3. It's just b to the 3. 3 minus 3 factorial is 0 factorial. And now again we have 3 factorial over 3 factorial, which is just 1. So now our final expanded polynomial, or cubic. So you always have, just to generalize, you always have a to the n and b to the n. Then you have, this just happenstance, but you have a n minus 1, b plus n times b times. It won't always look like that. This just sort of what you have. And you can use that to expand any sort of polynomial. Just be mindful that sometimes they might ask you for, let's say, the third value, or when k is equal to 1 or something like that. They might ask you for a specific value. That's really easy to plug in. But remember that if we had instead the term 3x plus, you must not forget these coefficients. Often during exams or something, you might speed through because you know the question, because you've done it, but you might not have done it with these coefficients. So do it with the coefficients and you'll have good practice, but do not forget to multiply this coefficient. Not only to multiply, but to multiply it with its exponent. Otherwise, you will have the wrong answer. Alright, hopefully that helped.